Hey everyone, welcome back. In this video, we will build a semantic search application using LangChain. Instead of searching for exact keywords, semantic search finds text based on meaning. I'm going to first show you the architecture. I have a PDF file that I'm going to load. Once we have this PDF file, we will do the chunking, and for that, we are going to use the method recursive character text splitter. Then we will use embeddings from Hugging Face. And once we have this embedding, we are going to store that into the vector database FAISS. And from this vector database, we are going to do the semantic search. And once we do that, we will get the output. So let's get back to the VS Code editor. Now I have to load this PDF file. So for that, I'm going to make some import statement from LangChain underscore community, LangChain underscore this one, community dot document loaders. I will import PyPDF loader, PyPDF loader, this one. And then I'm going to make a variable loader and I will call this PyPDF loader. I have a PDF file name known as story.pdf. I can share this with you so you can also experiment this with this. And once I have loaded it in this variable loader, I will make a variable docs and then I will call this loader, and from this the method load. So PyPDF loader will load the PDF and convert each page into a LangChain document, and we can quickly verify that as well. So let me write some print statement. Print, we will check the length of documents. It should be 3, and then print from this docs we are going to print pages dot page underscore content, and let's say I'm going to print 300, first 300, and then also metadata, print docs and then dot metadata. And before that, let me also show you the PDF file. I'm already having it here, story.pdf, and this is the PDF file that I am using. Now let me print and then we will see. So let me execute this. I will clear this, and now Python semantic search.py. It is loading now. So you see from langchain.community, the document loaders import PyPDF loader. It's taking some time. In the meantime, I'll show you this PDF. So it's just a random PDF that I have taken for this tutorial, and there are total 3 pages in that. So this is the first page. There are some chapter 1. Okay, here also you will see in the output it is generated. So you see here it is telling us 3, that is there are total number of 3 pages. Then this is the heading. You can see here the latent library of Silverwood, and then there are some other information like chapter 1, the hidden map, and so on. So this is the PDF that we are using here. Now let's go to the next step. So we will do this, we will create this into chunks. I'll make a variable chunks, and then I will call this text splitter. Okay, and no, I have not imported it yet, so let me first import that. I'll import it here from LangChain underscore, this time text splitters, the last one, text splitters import recursive character text splitter. I will import this, and now I am going to make, let me remove this, I'll do this later. I have to make an object of this, so I will write here text underscore splitter, and then I will call this recursive text splitter. And there are some parameters. So the first one is chunk size. Let's say this I'm going to give as 500. The next parameter is chunk overlap. Chunk overlap is, let's say it is going to be 100 here. So chunk size 500 means maximum characters per chunk, and this overlap is equal to 100 means repeat some text between chunks, so context is not lost. And then I'll make variable chunks, and then I will call this text splitter, and from this I will call the method split documents, and then I will pass our docs. So I hope I have saved, yes, here in this docs. So now this will create chunks for us. And yeah, so we can also print if you want. So let's say I will print on just length of chunks. And before that I'll just comment it out. I don't want to print everything now. Now let me execute the code. First I will remove this, and now let's see. So this will print now the length of chunks here. Let's see. And after that we will create embeddings. Yeah, so the length of chunk is here, it is 16. Now let's convert this chunk. So maybe I can just write here some steps so that you can remember. So step 1, load PDF file. Then step 2, convert PDF to chunks. Now we are going to the step 3, convert chunks to embeddings, so that you will also remember it. Now for that I'm going to load model from Hugging Face, from LangChain underscore Hugging Face, this one, from Hugging Face import Hugging Face embeddings. So this embedding I'm going to use, I'll make an object of this embeddings is equal to embeddings, and then I will call this Hugging Face embeddings, and inside this we will pass the model name that we will be using. So model underscore name, this is a parameter, and we are going to use sentence transformers slash all mini LLM, or I just have to write this LM, meaning then this M should be capital dash L6 dash version 2. I hope I have written this name correctly, otherwise we'll get some error during the runtime, but we will see. So the first time you run this model, the model will download automatically, and after that it runs locally on your machine. So we have done here, we are going to convert this to embeddings, and I'm not going to run this now. Let's go to the next step, step number 4, and here we will store these embeddings. So store embeddings into FAISS, that is the vector store. So let's do the import from LangChain underscore community, this one dot vector stores, import FAISS. So I'll make an object vector underscore store, and then I will call this FAIS. From this I will call the method from documents, and then inside this what we have to do, we have to pass our chunks that we have created and the embedding models, embedding, or I will just write here embeddings. So what we are passing here, the chunks that we have created here, this is a chunk, and then the embedding model. So it will convert this chunk into embedding using this embedding model, and then store it into this vector store object. Now we will run a similarity search, and for that, and then we will store the result in a variable results. I'll make a variable result, and then I will call this vector store. From this I will call similarity search, and inside this now I'm going to pass the question that I want to ask. So what key opened the hidden tunnel? This is one of the question that I'm asking from the document, and to print it I'm going to run a for loop here. I will write here for doc in results, then print from this document, we are going to print page underscore content. So this is, let me make this results. Yeah, page content. So this is the actual result we will see, and then just print. Yeah, so we will write this query, and then we will now create. Okay, let me write the steps. So this is step 4, step 5, sorry, step 5, and this step 5 is run a similarity search, because here we are using the similarity search function. And then let's go to the step 6. So now right now you are just going to run this, but you also have to get the results when you run a query. For that, what we need a retriever. So let's create a retriever in step 6, and for that I am going to make a variable retriever, and then I will call our vector store. From this I will call the method as retriever, and inside this we have to pass the parameter search type, search underscore type. What we are doing here, similarity. So I will write here similarity, and then search underscore quarks is equal to, I'll pass this in dictionary, this is going to be k, and let's say 3. So we are going to fetch the top 3 results. Here what we are doing, it will uses this similarity, will uses the similarity search, and k returns the top 3 matching chunks for the question that we are asking. So what I have done here, yeah, what k opened the hill there. So this is a similarity search, and now we are going to write the actual queries here. So I will make a variable queries, and let me pass 2 queries here as a list. So first is what did, so this Dev is a character in the story. What did Dev bring with him? And the next question, I'll put a question mark here. The next question will be what key opened the hidden tunnel? The same question. So here you can just ask one question, but here I'm passing 2 questions here. So instead of calling the invoke method, I have to call here batch method, because we are having multiple queries now. So I will store the result in batch underscore results, and then I will call this retriever, and from this I will call the method batch, and inside this I will pass the queries that I've written here. And now we have the last step, that is we have to display the results. So for this batch results, I'm going to write for query dot for a query. So this is our dictionary. So for query docs in zip, and then queries and batch results. So I'm going to zip both of this, the actual question and the results that I'm going to get, and then I will write, let's say, some print statements here, this, and then for I doc in enumerate docs 1, and then print. So I will write a f string, so print result of I, and then here let's say page, and then here metadata doc dot metadata, and this we will get from page underscore label, and then let's print. Maybe I'll get some error because I'm writing a lot of code now without testing it. Page content, and then print. Okay, let me first run and see if it is throwing some error or it is working fine. I'll call this. Now let's wait and see. So we will see the original query, page number, and the matching text. If the code doesn't break, that's the condition. Okay, so it is calling this Hugging Face embedding model from here. This is working. Yeah, so possible reason is similarity search I have written. Wait, yeah, spelling is incorrect. One. The second one is here I have to use single quotes, not double quotes. Now let's see if there are still some error remaining. I'll clear this. I'll clear this out and then I'll rerun this and let's see now what error I get. Okay, there are no more errors here. So this is the output that we are getting here for the query. Now let's see. So these are the query that we have asked. Wait, what did Dave bring with him? So for this query, we have this results. This is the result 1. We will get 3 because we have written here we want to return 3 results here. Yeah, this k is equal to 3. So here you can see they've brought a lantern, 3 old keys, and a pocket watch. So in that result 1 we got this answer here, so it is correct. Then we also found some answer here. They've discovered a narrow door with the 3 keyholes, and then we also found something in result number 3, that is page 2. Then we had this second query. The second is one is what key opened the hidden tunnel. So for that we have this result. So behind the main staircases Dave discovered a narrow door with keyholes. He tried first to nothing worked, and then so on. The tunnel led them beneath the bell chamber and out toward the fox shaped fountain. So this is the answer for the second one. And if I recap, so we have loaded the file with the PDF loader. See here, PDF loader, then we did chunking, embeddings, vector database, then we did retriever, and finally we got the result. So since this is a semantic search, we don't use LLM model here. There is no need of LLM. When you do RAG pipeline, when you include a LLM in this, so it becomes a RAG pipeline. I hope you found this video helpful. If you like my video, you can subscribe to my channel. Thank you for watching.